In the vastness of the Pacific, there's a place unlike any other. Enchanted volcanic islands that are home to a remarkable collection of animals and plants. Here, evolution is proceeding at extraordinary speed. Galapagos. A place of wonders. Millions of years ago, the islands were colonized by a strange cast of characters. But to settle in this harsh, unforgiving landscape, those new arrivals had to dramatically adapt their bodies. Today, revelatory discoveries are still being made about them. And from their story, we can piece together how Galapagos came to be one of the most diverse environments on our planet. It's perhaps surprising that the Galapagos should have become famous for its biodiversity. For the fact is that living conditions here are very tough. On the equator, the heat is intense. There's very little water. Much of the land is covered by bare volcanic rock. And yet every species that lives here is descended from an ancestor from the continents that have taken on these conditions and won. And the way in which they did so is extraordinary. The total land area of the 16 islands and rocky outcrops that make up Galapagos is less than half that of Wales. Yet, for its size, there are more unique species here than anywhere else on Earth. Why should that be? There are clues hidden within the landscape. This crescent-shaped strip of cliffs rising steeply from the Pacific Ocean is the island of Tortuga. And like all the Galapagos Islands, it's a wonderful place to see wildlife. Here and there, there's a sea lion, and above that, nesting seabirds, boobies and Galapagos gulls. But you only really appreciate the true character of this island from the air. From here, it's clear that this is the last fragment of an extinct volcano. These curving cliffs are all that remains of what was once a completely circular crater. And that is an indication of something very significant about all these islands. They change with enormous rapidity. The history of these islands is very much the same. Each is born on the bottom of the sea and rises up through the waters to emerge as a volcano. This is a typical Galapagos island in its infancy. But then, after 1 million years of eruptions, volcanic activity ceases. 2 million years after its first appearance, the island is approaching middle age. It has a moist climate and is covered by forest. it begins to sink under its own weight of ash and lava. It's battered by erosion, and after 4 million years, it's near the end of its existence. Low-lying and arid with little rainfall, it's surrounded by beaches of soft sand. The waves and rain continue to take their toll until all that is left is a craggy outcrop of rock. These islands, in geological terms, are very short-lived. Today, there are islands in the Galapagos archipelago that illustrate every stage in this history. The youngest in the west are arid, black, and still breathing fire. The oldest in the east have long since ceased to erupt. But each island provides its colonists with a range of habitats. And it is the youngest active islands that pose the greatest problems for any animals that attempt to colonize them. In the far west of the archipelago lies Fernandina. This is the youngest. And in adapting to this place, it has become like no other animal on Earth. Behold, the marine iguana. But eating nothing but seaweed creates another problem: too much salt. The marine iguanas dealt with that in a very particular way. They evolved a special gland in their nose. They simply sneeze the excess salt from their blood. These changes had to happen very quickly in evolutionary terms if the iguanas were to survive. But here, conditions sometimes change, and then even iguanas struggle to keep up. Every 3 to 7 years, the weather becomes very extreme and irregular. It's a phenomenon called El Niño. And it can have a devastating effect on wildlife. Evolutionary biologist Maren Vetusek has studied the effects of El Niño on the Galapagos marine iguanas. She discovered that it decimates their food.
Crest is 1.0. Marine iguanas usually eat red and green algae, and that algae dies off completely during El Niños, during strong El Niños, and is replaced by a brown algae. And marine iguanas aren't able to digest the brown algae, so they can eat it, but it sits in their stomach, basically in a big lump. And so you can find iguanas dead on the beach of starvation with their stomachs full of this brown algae that they're just not able to digest.
The marine iguana is the worst affected of all Galapagos animals during an El Niño. As many as 90% of them can perish. It's bad news for iguanas, but good news for scavengers. But now, new research has shown that the iguanas have evolved an extraordinary way to survive the famine. They shrink.
So we saw that the largest animals were decreasing their body length by as much as 20%. And the magnitude of that means that it can't be simply that they're changing their cartilage or connective tissue or resorbing muscles. Those things together account for about 10% of length. So instead, 20% of shrinkage really indicates that it's got to be the skeleton itself that's decreasing in length.
This amazing ability to reabsorb bone in times of hardship is unique to these reptiles. It's the most recent discovery in understanding how the marine iguanas managed to survive on the coastlines of the youngest Galapagos Islands. Iguanas are not alone in eking out a living on this desolate Fernandina coastline. Every animal and plant has found its own way to survive. All are dependent in some way on the riches of the ocean. But away from the coast, there's barely any water at all. There, it's too dry and too hot for most forms of life. But in time, that will change. As the island ages, this hostile landscape will become a little more welcoming. It will, one day, support a rich forest full of new places for animals to live. This change is driven by the volcanic hotspot which brought the island into existence. The eruptions continue. 95% of its final bulk will accumulate in the next few 100,000 years. By the time the eruptions have ceased, it's grown so large that it has acquired a new power. It has the ability to create its own weather. Santa Cruz, in the center of the archipelago, is typical of these middle-aged islands. Its slopes are covered by a mantle. Trees tend to have big seeds, and a few of those made it across the oceans to the Galapagos, and certainly none up here into the highlands. But smaller plants have smaller seeds, some so small they can float on the wind. And one member of the dandelion family made it up here. And without competition from other trees, they grew big. This, you could say, is a forest of giant dandelions. This very special kind of dandelion is called Scalasia. It's unique to the Galapagos and flourishes on the high slopes of Santa Cruz and other middle-aged islands. Appear. Here, dragonflies thrive, and once again, they belong to a species that occurs nowhere else but here. But the water's downward journey continues below ground to provide for a much stranger form of life. Deep under the Scalasia forests of Santa Cruz, there is a hidden network of mysterious lava tunnels. Here, the species-changing power of Galapagos is still active. For scientists like caver Aaron Addison and biologist Steve Taylor, these lava tubes are the Galapagos Islands' new frontier of discovery.
It is difficult to imagine or indeed believe that there are still such untouched areas within a place that's so well known as the Galapagos and so well studied. But we do find those areas, and those areas then lead us to new species that are unknown to science or that haven't been described by anyone else ever.
Black volcanic rock still lies only a few inches down beneath the forest trees of Santa Cruz. It erupted millions of years ago and flowed down the sides of the infant volcano in rivers of molten red-hot lava. As the surface of the lava cooled, it solidified and formed a rocky skin. And when the eruption ceased, the still liquid lava continued to flow away, leaving behind these huge empty caverns. And now, a constant trickle of life-giving water drips down into the winding tunnels. Steve Taylor is an expert on underground life. The subterranean world is full of surprises.
It's just really exciting because these animals are pale and eyeless. There's no selective pressure to maintain eyes in a cave, so they're blind, and they often have elongate appendages, so they can either find prey or avoid prey.
This amblypygid, half scorpion, half spider, is a predator and a scavenger. It might seem ungainly, but it's well adapted to this black habitat. Eyes are useless down here, and it's become almost totally blind. Instead, it feels its way through the cave with great skill and sensitivity. 2 of its 8 legs are greatly elongated and capable of extending to twice the length of its body. This millipede has lost all its colour. Why spend precious energy creating a pigment in a place where no one can see it? Spiders, too, haunt the lava tubes. And just like the tortoises and iguanas, these creatures have evolved into many different species. There are 90 of them, all unique to the Galapagos. Such variety in such a small area seems extraordinary. But in the Galapagos, it's almost common. The huge number of differing habitats has made Santa Cruz a centre of biological diversity. And as an island ages, so it develops more habitats. Now it's entering its old age. It's no longer growing. Its sheer mass is too heavy for the Earth's crust to support. It begins to sink under its own weight. And now the rainwater that has been falling on it throughout its middle age begins to carve away its substance. So the island becomes smaller, drier, and flatter. That is what has happened to Hispaniola. It's nearing 4 million years old. Its forests have gone. But it now has a different range of habitats. Millions of years of erosion have created beaches of soft sand, and they suit some animals very well. Have also adapted to live on these 4 million year old beaches. The enormous waved albatross, with its 2.5 meter wingspan, uses the gentle sloping surface as a runway. As you might expect, the species of albatross that lives here is slightly different from those found in other parts of the world. These wave-like patterns on its neck feathers distinguish it from all other albatross species. All albatrosses spend most of their lives on the wing, traveling across entire oceans. Here on Hispaniola, the waved albatrosses can nest. The isolation of the Galapagos and the protected soft shingle beaches of Hispaniola make this aging island an excellent breeding ground for them. 35,000 settle here each year. Waved albatrosses are monogamous. They mate for life. But how do you find a new mate or recognize your old partner in such a crowded colony? You dance. The whole performance can last for nearly an hour. And it's repeated several times every day. Sometimes a potential rival steps in to try his luck. The female in the middle dances with both enthusiastic males at the same time. The reward for the victorious male is great. A mate. And an opportunity to pass on his genes. The many habitats of Hispaniola and all aging Galapagos Islands were created by the erosive power of sea and weather. But erosion can have only one final result. Destruction. A Galapagos island worn down by the waves and the weather eventually reaches the last stage of its existence. After millions of years sustaining life, all that remains of it above water is a rocky, curving cliff. Like Tortuga. There are many relic islands like Tortuga in the Galapagos. Devil's Crown in the south of the archipelago is even closer to disappearing altogether below the waves. But even in its final days, a Galapagos island provides a habitat for some. Its rock has been turned by erosion into sediment, and now that fertilizes the marine life around its submerged remains. A ring of coral 2 meters wide encircles its dwindling stump. So a whole new animal community develops. Corals are at its center. Bristleworms hide inside them, occasionally emerging to browse on passing morsels. Fish find safety among their branches. And some of these species, once again, are unique to the Galapagos. The reef teems with life. So even in the last stages of its life, a Galapagos island can support a rich animal community. But remarkably, even this is not the end of the story. Because even when an island has totally disappeared beneath the waves, it continues to influence life in the surrounding seas. The remains of ancient Galapagos Islands stretch for hundreds of miles across the Pacific seabed. These were once volcanoes like Fernandina, vegetated mountains like Santa Cruz, and low-lying nurseries like Española. Today, those environments are long gone, but the remnants of the islands under the sea are still key in the lives of one of the ocean's most magnificent inhabitants. Up to 12 meters long, it's the largest fish in the world. The whale shark. Whale sharks come to the Galapagos in large numbers at the same time every year. But why they do so is a mystery. Marine biologists Alex Hearn and Jonathan Green have spent the last 5 years trying to solve the puzzle.
If you think about how Galapagos is formed and how the currents work, the most productive waters are actually out west. So you would have thought that if whale sharks were coming here to feed, they'd be out in the west of the archipelago, and they're not, they're up north. So why are they coming here? It's clearly not to feed. What we found out recently is that it's mainly large pregnant females. Are they coming here to give birth? This may be the pupping ground for whale sharks. I'm slightly skeptical. I think we'd have seen juveniles, and we don't. So that brings back the question, well then, if they're not pupping here and if they're not feeding here, why are they coming?
To understand the whale shark's migratory patterns, Hearn and Green attach satellite tags to the sharks they encounter. This enables them to track their movements. and it's revealing some extraordinary new facts. First, the sharks swim open-mouthed through the rich waters off the west coast of South America. Then they continue their journey westwards to the Galapagos. But they only spend a few days at a time in the island's waters, before continuing westwards out into the open ocean. Nobody has yet proved why the whale sharks do this, but Alex Hearn has begun to formulate some ideas.
I think there are two possibilities. Firstly, they may be using Galapagos as a waypoint which directs them towards their pupping grounds. The other option is that Galapagos may be providing a service for them along the way, and that service may be cleaning, because we do see a lot of cleaning behavior from the reef fish, or it may be a combination of the two.
The long line of submerged Galapagos Islands could play a central role in the whale shark's extraordinary journey. It might be that they serve as signposts by which the sharks navigate.
If you start looking at where they're going, and especially the tracks that we have along those ridges and then up to the next ridge and then back down again, it certainly seems that they're associating with those ridges for one reason or another, and that could be geomagnetism, or it could also be something to do with the biology of the water column above those ridges. But certainly something is going on.
From their birth to their death, the islands have acted like evolutionary pressure cookers. From the youngest islands like Fernandina, the middle-aged ones like Santa Cruz, and the old islands like Española. They're extremely varied, with contrasted conditions. Deserts, rainforests and polar waters crowded together in a very small area. These huge variations have created a wide range of opportunities for the few animals that have managed to reach here. As they colonized, so they adapted and consequently flourished. That explains many of the oddities of the inhabitants of these islands. Including that most fundamental phenomenon of all, the appearance of new species. The giant tortoise is the very emblem of the Galapagos, and in their heyday there were hundreds of thousands of them. Not only that, there were 15 different species, each in its own locality. But why should there be so many species within such a comparatively restricted area? In the next program, we'll look at the deep geological forces that can make a single species produce many and turn the Galapagos into this wonderland.
And if you want to discover how this incredible documentary was made, then stay right here for Making Attenborough's Galapagos in a couple of minutes.